Okay, we are on slide 40. We are talking about geometric sequences today. We're going to finish up the digital interactive notebook today. Geometric sequence is a sequence of numbers where each term after the first is found by multiplying the previous one by some ratio. The ratio is called your common ratio. So we are going to look at these sequences and determine what that common ratio is and find the next terms in the sequence. So our first term is 648. So 648 is going to be multiplied by some ratio to get negative 216. So the way we find that is by doing division. So we divide negative 216 by 648. And then, I guess I should show y'all my calculator. Hopefully it works today. Okay, so we divide the second by the first, and it comes out as a decimal, so we need to hit math frac. So our ratio is negative 1/3. So we need to check and see if that works for the next number in the sequence. So let's multiply negative 216 times a negative 1/3. Comes out with 72. What's the same thing as multiplying by a negative 1/3? Yeah, dividing by a negative 3. So divide by negative 3 on the next one to find the next term. Negative 24. Or if we did 72 times, wrong thing, times the negative 1/3, we should get negative 24. So you can do it by dividing by a negative 3 or multiplying by negative 1/3. So our next term in the sequence is negative 24. Okay, and then we need to find the next one. Divide by negative 3, and what do we get? Negative 24 divided by negative 3. 8, yeah. Then we need one more. 8 divided by negative 3. It's a fraction, isn't it? So divide by negative 3, divide by negative 3. Negative 2.6 repeating. Or we can leave it as hit math frac, negative 8/3. So negative 8/3. Okay, let's go to the next one. We need the next 3 terms. So we have 25, and it goes to negative 5. So how do you go from negative 20 and multiply by something or divide by something to get negative 5? What is it?
Negative 5.
Yeah, divide by negative 5. So 25 divided by negative 5 is negative 5. Negative 5 divided by negative 5 is 1. And now 1 divided by negative 5. Negative 1/5, right? So 25 divided by negative 5. Divide by negative 5. Divide by negative 5. Divide by negative 5. We can leave it just like that. How about we leave it like that? So this one could have been negative 0.2. And then divide by a negative 5. It's positive 0.004. No, just 1 0, sorry. And then divide that by -5. Because if you're, divide by -0.008. And I want us to go ahead and write what the R is. R is going to be our common ratio. On this one, R was -1/3, right? And on the other one, it was -1/5. There we go. And our A1 on these is the first term, 648. Let's also write what that is. A1 equals 648. And here, A1 equals 25. Okay, so let's look at our formula for geometric sequences. This has the same like AN, and then it has A1, and then it has R, but it still has the N minus 1. So AN means the nth term, whatever that is. So let's say it's the 5th term, 22nd term, whatever. And then your R is the common ratio. When we had arithmetic sequences, it was the common difference. But this is a ratio because you're multiplying. Difference, you're adding or subtracting, depending on if it's positive or negative. So let's write an equation for the nth term of this geometric sequence. So we need to identify what our common differences and what our first term is. Let me move this up so y'all can see it better. So our A1 is our first term, is -2. We just need to find R. So we look at from -2 to +10. What is the common ratio? What would -2 have to be multiplied by to get 10? Yeah. So let's write what that formula is. So it's AN equals A1, so -2. I'm going to put -2 in parentheses to make this bigger. And then times your R, so -5. And then raised to the N minus 1. And we leave it just like that. We can't multiply these because we have an exponent first. But if we want to find one of the terms, we'll use that. Let's write this down in our journal, though. Okay, so go ahead and open up your journal. Okay, so we have A1 is the -2. R is the -5. And then our formula is A sub n equals -2 is -5 n minus 1. So that means our exponent is going to be something n minus 1. So what we're going to do with this formula is we are going to check the third term to make sure the formula does actually work. With arithmetic sequences, we could distribute and simplify, but here we can't because order of operations say parentheses. We can't do anything within that parentheses. Then exponents, we can't do anything with that exponent. And then multiply and divide. But before we simplify and start multiplying this must be done. So that's why we cannot simplify it. So we're going to do A3 equals, for our third term, -2 times a -5 raised to the 3 minus 1. Now we can simplify the exponent. So this is your first, what you do first. So still -2 times -5. 3 minus 1 is now 2. Raised, or squared. Raised to the second power squared. So then order of operations next. So exponents or parentheses, now exponents. -5 squared. What is -5 squared? Positive 25 times the -2 equals -50. So A3 is -50. Let's do another one. Another sequence. 3, 9, 27, ... So our A1 is 3. What's our common difference?
3.
Yeah, because 3 times 3 gives you 9. 9 times 3 gives you 27. What would the next term be? $27 times 3, what is that? Huh? 81. Okay. So let's write our formula. AN equals the A1, so it'd be 3 times the common difference, or the ratio, common ratio, to the n minus 1. Let's find the fourth term. So A4 equals 3 times 3, 4 minus 1. Which we already know the fourth term, but we're just checking to make sure that our formula works. So this would still be 3 times 3 because we do the exponents first. 4 minus 1. That's a bunch of 3's. And we do exponent first, so we got to do 3 cubed. What's 3 times 3? Times 3, yeah. 3 cubed. 27. Times 3? 81. So our A4 equals 81. We're going to see a geometric sequence after Christmas again. So this is just a preview of it. So we're not getting super into it. Not too bad though, right? It's not too bad. Huh? It's easier, yeah, because you don't have to distribute. All right, so let's talk about our types of sequences. Just a little review. For arithmetic, how do we know that it's arithmetic? Yeah, you're adding by common number, right? A sequence in which the previous or the new term is found by adding a number to the previous.
Wait, but couldn't you subtract 2? Or is it just...
Yeah. So we could put in there slash subtracting. Yes. There we go. Can y'all see that, or is it too small? There we go. That's a little better. A sequence in which the new term, or the next term, I think next term is found by adding or subtracting a number to the previous term. To/from. So let's come up with an example. It can be an easy one. Let's start it out with like 5. What do we want to add by? Huh? 5? Is that what you said? Okay. So what would the next term be? What would the next one be? So it's 5 is being added each time. Okay, how could I change this definition? I'm going to copy and paste it down here so that it's representing geometric now. A sequence in which the next term is found by multiplying or dividing a number. It'd be by the previous term. So a sequence in which the next term is found by multiplying/dividing a number by the previous term. Let's come up with an example. Let's start out with 2. What do we want to multiply by? Let's multiply by, I don't know. What do y'all think? 2? So 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. 16 times 2 is 32. 32 times 2 is 64. And then neither. How can we describe a sequence that is neither? Say what? No, we need to define it. What would be a definition of a sequence that is not geometric or arithmetic? Just by looking at them, how would you know? It what? Yeah, doesn't have a pattern of adding, subtracting, or multiplying, dividing. A sequence that does not have a pattern from one term to the next, pattern of adding, subtracting, multiplying, or dividing from one term to the next. I think that covered it. A sequence that does not have a pattern of adding, subtracting, multiplying, or dividing from one term to the next. By the same number. Like your common difference or common ratio. That's what I'm looking for. A common difference or common ratio. If it doesn't have a common difference or ratio, then it is not an arithmetic or geometric sequence. I'm going to give you an example. And y'all tell me what the pattern is, though. One, 4, 9, 16, 25. It doesn't have a pattern from one to the next. But do y'all know what this pattern is? Or what these numbers are? Plus 3, plus 5, plus 7. But what are these particular numbers? What kind of number is 4? What kind of number is 9? Even odd, even odd. But how do we find 9? What's the only way to multiply to get 9? 3 times 3. What's a way to get 4? So 2 times 2, 3 times 3, 4 times 4, 5 times 5. So it's the perfect squares is what that is. Okay, another one is 1, 1, 2, 3, 5, 8, 13, 21. So 1, 1, 2, 3, 5, 8, 13, 21.
Oh,
What is the pattern?
isn't that like it's adding 1 plus 1 and 2 plus 3?
Say it louder.
It's adding 1 plus 1 and 1 plus 2, 2 plus 3, 3 plus 5, 5 plus 8, and then 8 plus 13.
Yep. I think it's called the Fibonacci sequence. I gotta make sure. Fibonacci sequence is what it's called. Where a number is the addition of the last two numbers, starting with 0 and 1. Oh, there was a 0 there. Whoops. There we go. That's called the Fibonacci sequence. Okay, let's go to 42, slide 42. Arithmetic, geometric, or neither. So you're going to work on this one by yourself. Decide whether it's arithmetic, geometric, or neither. I'm going to pause the video. All right, the first one, what is that? Okay, why is it arithmetic? Adding 5. Okay, the next one? Okay, why geometric? Multiplying by 2. Okay, the next one? Okay, why? All right, divided by 2. The next one? Okay, why? Okay. And then the next one? Neither. The next one? Okay. Add an extra. All right, cool. Okay, we're not going to do recursive formula right now. So I have an assignment for y'all to work on, and I'm also working on your test review. I'm going to work on getting it printed out so that you're ready for your test on Friday. So I'm going to work on that while you do your first assignment, which is part of the review.